Greetings 8th grade. Today we're talking about addition and subtraction equations. Now this is something that's familiar from past years, I hope, so it'll be a little bit of review, but there is also a couple tricks we need to know to refresh dealing with positives and negatives, decimals, and fractions and mixed numbers. So here we go. Let's just talk about how can we think of equations. And this is what I like to think. I like to think of scales because with the equal sign we know that we have things that are balanced. So if scales are balanced, then you have the same amount on both sides, just like in equation. The equal sign tells us that two things are worth the same value. So if we're looking at this, we can see we're using algebra tiles again like we have in the past, and I like to think of this as showing an equation. So again, we're going to show that the equal sign is what's balancing the right and the left. And what do we have on the left? Well, we have this X box, and I know that is not the game that you would like to play the most since this is math, but maybe it is. At least for me it is, because you know I would pwn you in those other ones. But here we go. So we have the X box, and it's a box that I like to imagine as like a little, just a little thin, weightless paper box that's hiding a number of algebra tiles, but we don't know how many it's hiding, so it doesn't have any value just as an X box. It's hiding a value and we don't know what that value is, so we have just one X box and we don't know how many tiles are in it. And we also have 3 tiles, so what do we have on the left? We have an X box and we have 3 tiles, and what's that equal to? Well, on the right we have 6 negatives, so we can call that -6. Now I know a lot of you can maybe look at this equation and determine what is the X box equal to, what must it be hiding right away, but we're going to use this image and this sort of idea to talk about how we can solve this equation and more difficult ones where you can't see it quite right away. So you didn't need to include that yet, but we're going to take it all down in a second. As for right now, let's move on and talk about the notes we need to take. Any equation, whether it looks simple like that or it's more difficult, we're going to start off with step 1, and that's to draw the scales of justice. Now that scales of justice is really that middle beam, and you'll see what I'm talking about in a minute, but we're just drawing that scale beam to show that we have equivalents on either side, equivalent values, and no matter what we do to the left, we must do to the right to maintain that balance. Just like with real scales, if you're going to add something really heavy to the right side, like Mr. Schwartz, then you better add something really heavy with the same weight, like a hippopotamus, to have it stay balanced. So anything we do to the right, we must do to the left, and we'll do the same thing to both sides to make sure that it maintains that balance. Step number 2 is to locate the variable, because what we're trying to do is we're trying to get that variable, that X box, just to balance with something. That way, without lifting it up, we'll know what it's equal to. We'll know what it's hiding. We'll know the value in the X box if we can get it to balance with something, because they must be equivalent. And how are we going to do that? Step number 3, we're going to isolate the variable by undoing what's been done. Undo what's been done. Many of you have heard me tell the story of a teacher who used to sing that little phrase, we got to undo what's been done. And so what we're going to do is we're going to isolate the variable, get it alone to see what it balances with by getting rid of everything that's with it on that side of the scale. So for example, number 1, I'm going to ask you to draw these scales and then also to include all of the writing that I'm going to include. We said earlier that this is kind of like x plus 3, or it is x plus 3 on the left, and again here are the scales of justice. So we put the equal sign right in the middle of the scale because it balances, and on the right we have -6. Now when I say draw the scales of justice, usually we'll draw vertical lines that help us remember that things must be balanced. Step number 2 is find the variable. Our variable in this case is x, so find the variable, and it's x, easy enough. Now what are we trying to do? We're trying to isolate the variable by undoing what's been done. So there's a number of ways to think about this. One way to think about it would be to say, well, 3 has been added to x, so I can just take away 3 from the left side. And that's undoing what's been done. But again, whatever we do to the left, we must do to the right. Can I take away 3 on the right side? I can't, so this would be unbalanced. That's one way to think about it, would just be to say -3, but knowing 0 pairs, we know that we can also get 3 to cancel out +3 by adding -3. And if we add -3 to the left side, we can keep it balanced by adding -3 to the right. Now these will cancel out, and we'll be just left with x balances with negative 9, or 9 negatives. Now what does that look like if you're just writing the equation? Again, I want you to draw this picture to get full credit on your homework, but in the future we're just going to write and do the numerical representation. What we did there is we kind of subtracted the 3, or another way to think of it is what we actually did is we added 3 negatives. And so if we add 3 negatives to both sides, which is what we did, and that's an equivalent move, so we're still maintaining balance, those would cancel out just like they did, the 0 pairs, and we have x is equal to 9 negatives. So this is about the normal work you'll usually show, but this is kind of what's going on and why it makes sense to do what we do, trying to use the familiar idea of scales that we are familiar with. I'm going to erase this, but you got to have it all, both the numerical representation and the scales of justice with all that marking. And we're going to go on to some other examples where you won't have to draw the scale. So let's see what that looks like. Number 2 says negative 28 plus p equals negative 43. This is going to be easy enough if we just follow our steps. Step number 1 is to draw the scales of justice. Those are kind of wonky. Step number 2 is find the variable. It's a p, so we need to isolate p by undoing what's been done. What's been done to p? Well, negative 28 was added. How do you get rid of negative 28? You can subtract negative 28. You can subtract or get rid of exactly what is there. We'll subtract the negative. Another way to look at that is just to say, if you have 28 negative tiles, how could you get rid of 28 negative tiles? By adding 28 positives. And we know that with add ops, that's the same thing. Now those will cancel out on the left. Again, this was an equivalent move to add 28 to both sides of the scales. And we're left on the left with just the p is left. It falls down. And on the right, if you have 43 negatives and 28 positives, you have to cancel out, but you have more negatives than positives. Final answer would be 15, negative 15. So we subtracted the values, but we knew the answer was going to be negative because we had more negatives than positives. Okay, let's move on to number 3. It says 2 1/5 is equal to, okay, so 2 1/5 is equal to negative 1/6, negative 1/6, plus the opposite of a number. And for a number, let's just use the variable n, plus the opposite, that means negative, plus the opposite of a number. So what are we going to do here? Well, of course, we're going to draw the scales of justice. The second step is we're going to locate the variable. Our variable is n, and we need to undo what's been done. The first thing that's been done is negative 1/6 has been added. How can you get rid of negative 1/6? Well, with a positive 1/6. We can add 1/6 to both sides. After we do that, these will cancel out. That's the same move, so it's equivalent. I would like you to show that we're doing the same thing to both sides. That's why it's staying balanced and equal. And if we're going to think about 2 1/5 adding 1/6, we need to have the same size pieces to add together. So we can cut those up, make some extra cuts, and that would be 6/30 plus 5/30. Whatever I multiplied the denominator by, I multiplied the numerator by. And we're going to have 2 11/30. Now here's the tricky part, is a lot of people will just say, oh, that's what our variable is equal to. But we've only canceled out negative 1/6, and what is left is the opposite of n, or negative n. And usually when you're solving equations, they want you to tell what is the variable equal to. Well, if I know the opposite of our variable, or the opposite of n is equal to 2 11/30, then what is just n equal to? So if the opposite turned positive, then the regular variable must be equal to negative 2 11/30. So I chose that as an example because I wanted you to kind of pick up on that sometimes you're going to have a negative variable that falls down, and then you just have to flip the signs. What you're actually doing is multiplying by negative 1. But we're just finding out, what is the normal variable equal to? What is it equal to in its positive form? Make sure you have all those notes, all those answers. Show all those that work, and I'm going to leave you with some problems to do on your own. Again, please follow these steps. Show your work moving downwards. Draw those scales of justice, scales that keep us balanced. Find the variable, and then isolate the variable by undoing what's been done. Here they are. First one is negative 6 12/100 plus m is equal to 41 9/10. So find out what m must be equal to. Remember your decimal rules. And the second one is 2/3 more than j is -5/9. Find j. So you're going to need to be able to write that as an equation and then solve for the value of j. Good luck. I'll see you later.